Greetings, this is the Critter Podcast, and I'm Callie Cross. Today's episode is about the fascinating mathematical formula that might just tell us whether we're alone in the universe. We're diving deep into the Drake equation, a brilliant piece of cosmic detective work that estimates how many alien civilizations could be out there right now, potentially looking up at their own night skies and wondering the same thing we are. Now, I know what you're thinking. Math and aliens? But trust me, this equation is way cooler than anything you suffered through in high school. It considers everything from star formation rates to the likelihood of planets developing intelligent life. And the results? Well, they're both thrilling and humbling at the same time. Could there be thousands of alien civilizations in our galaxy alone? Or are we a cosmic fluke, the only ones pondering our existence in this vast ocean of stars? Stick around as we break down each variable, explore what modern science has revealed since astronomer Frank Drake first scribbled this equation in 1961, and discover what it all means for humanity's place in the cosmos. Right now, somewhere in our galaxy, there could be an alien civilization pointing their telescopes at Earth, watching dinosaurs roam. They don't know we're here yet because our radio signals, our cosmic "hello, we exist," won't reach them for another 1,000 years. And when they finally respond, we'll be long gone, unless we figure out how to stick around. This isn't science fiction. It's the terrifying math of the Drake equation. And it reveals something profound about whether we're alone in the universe or just cosmically terrible at timing. Picture a mathematician staying up all night before a big meeting, scribbling on paper, trying to organize the biggest question humans have ever asked. Are we alone? That was Frank Drake decades ago, and by morning he'd created something brilliant. Not an answer, but a framework. A way to take an impossibly huge question and break it into pieces we can actually think about. How many stars are there? How many have planets? How many planets could support life? And here's where it gets dark. How long do civilizations like ours actually survive before we fade away or go silent? Think of it like trying to figure out how many pizza places in America are open right now, deliver to your area, and make deep dish specifically. You'd break it down step by step. The Drake equation does the same thing for alien civilizations. Except instead of pizza, we're looking for radio signals from beings who figured out technology, survived long enough to use it, and are broadcasting into the void, hoping someone's listening. Here's what makes this equation fascinating. It's basically a cosmic shopping list of probabilities multiplied together. Start with the number of stars in our galaxy, somewhere between 200 and 400 billion. Already your brain can't handle that number. Now, how many have planets? Turns out almost all of them. We didn't know that when Drake first wrote his equation. We hadn't found a single planet around another star. Now, we've found thousands, and the data is clear. Planets are everywhere. They're not special, they're the rule. Next question. How many of those planets are in the Goldilocks zone? Not too hot, not too cold, just right for liquid water. About 1 in 5 sun-like stars has an Earth-sized planet in that sweet spot. Do the math, and that's tens of billions of potentially habitable worlds in our galaxy alone. Tens of billions. Places where water could pool, where chemistry could do its thing, where life might emerge from non-life the way it did here. But here's where the equation gets uncomfortable. Even if planets are common, even if life is common, we're not looking for bacteria. We're looking for civilizations advanced enough to send signals we can detect. Life that evolved intelligence, developed technology, built transmitters, and decided to broadcast. That's a lot of filters. Each one narrows the pool. And the final variable is the one that keeps scientists up at night. How long do technological civilizations survive? Think about us. We've had radio technology for barely over a century. We've also had nuclear weapons for 80 years. Climate change, artificial intelligence, synthetic biology. We're at this weird, fragile moment where we have world-ending power, but toddler-level wisdom about using it. What if that's normal? What if every civilization reaches this point, and most don't make it through? If the average technological civilization survives 100 years before fading away or going silent, then at any given moment, there might only be a handful of civilizations in our entire galaxy. But if civilizations typically survive millions of years, if getting through the danger zone means you're basically set, then the galaxy could be absolutely packed with ancient, unimaginably advanced societies. The difference between those two scenarios is everything. And we have no idea which is true.
My name is Tom Sachs. I'm an artist in New York City. For nearly 2 decades, I have been collaborating with Nike.
Nike running is for runners, Nike basketball is for basketball. Nike craft is for everyone else.
Here's the part that feels like cosmic horror. We've been listening for over 60 years, with increasingly sophisticated technology. We've heard nothing. The famous wow signal detected back in the 70s, a powerful narrowband burst that lasted 72 seconds and never repeated, remains unexplained. Maybe it was aliens. Maybe it was a comet or satellite. We don't know. But mostly, silence. Just the background hiss of the universe doing its thing. Pulsars spinning, gas clouds glowing, stars being born and dying. No voices calling back. Maybe we're looking wrong, trying to find Wi-Fi signals with an AM radio. Maybe advanced civilizations use communication methods we can't even imagine yet. Or maybe the distances are just too vast. Our own radio signals have only traveled about 100 light years into space. That's reached maybe 0.1% of our galaxy. We've barely announced our existence, and we're already wondering why nobody's throwing us a welcome party. Or maybe the truth is darker. Maybe there's something called the Great Filter. Some challenge that almost no civilizations overcome. Either it's behind us, and we're extraordinarily lucky to exist at all, or it's ahead of us, waiting. Nuclear war, runaway climate change, an asteroid we don't see coming. Some other existential risk we haven't even identified yet. The Drake equation doesn't just ask if aliens exist. It asks if survival is normal or exceptional. But here's where I find strange hope in all this. We're living in the first generation that might actually answer this question. Not with philosophy or speculation, but with data. The James Webb Space Telescope is analyzing the atmospheres of distant planets right now, looking for chemical signatures that shouldn't exist without life. Oxygen and methane together. Industrial pollutants. Maybe even chlorophyll, the signature of photosynthesis reflected in a planet's light. Within decades, we might detect biosignatures. Proof that life, at minimum, isn't unique to Earth. And if we find nothing, that's an answer too. Maybe we're the first. Maybe intelligence is so rare, so cosmically improbable, that we're it. The universe is one shot at understanding itself. Which means every human life, every thought, every discovery, every terrible mistake we make, matters more than we can comprehend. We're not just another civilization in a crowded galaxy. We're the lone candle in a dark room the size of the universe. That's the weight the Drake equation puts on our shoulders. Either we're common, part of a vast cosmic community we just haven't met yet, or we're impossibly rare, And our survival determines whether consciousness continues in our little corner of space. Both possibilities are equally humbling. Both are equally terrifying. Both are equally wonderful.
Building a new product? Temez Labs takes you from napkin sketch to the App Store. Trusted by Fortune 500s for quality, security, and speed. Book your free strategy session at temez.ai.
So when you look up tonight and wonder if anyone's looking back, know that scientists are wondering the same thing, with billion-dollar telescopes and equations scribbled decades ago. We're searching, we're listening, we're doing the math. And every night we don't hear anything, we're left with the same question that's haunted humans since we first looked up. Are we alone? Or are we just early? Just late? Just too far apart? Or just not listening right? The Drake equation can't answer that yet, but it gave us the framework to keep asking, keep searching, keep hope alive that somewhere out there, someone's pointing their telescopes our way, watching our past, waiting for our future signals to arrive, wondering the same thing we are. Maybe they'll outlast their danger zone. Maybe we'll outlast ours. And maybe, thousands of years from now, our descendants will make contact with theirs, and two civilizations that beat the odds will finally say hello across the cosmic dark. Until then, we keep listening, we keep looking, and we do everything we can to make sure we survive long enough to hear the answer. Thanks for listening to the Critter Podcast with me, Callie Cross. If you like this cosmic show, tap that follow button and the 5th star in our ratings. And remember, the truth is out there.
Grab news. Tamez.